This is a fully working 3D printed Chevy LS3 V8 engine model, complete with moving pistons, valves, rocker arms, and an adjustable electric drive. In this video, we are building it step by step. You can get the complete hardware kit at makerrx.com, so you can spend less time searching for tiny parts and more time building. Hey makers, today we are assembling the complete Maker, our LS3 V8 engine model from the bare engine block all the way to the first powered test. If you enjoy 3D printing, engines, and mechanical builds, subscribe now and comment which engine you want us to build next. Before starting, prepare the printed parts, the MakerRx hardware kit, and the recommended tools. You will need small drill bits and a pin vise, an M3 tap, Allen keys, small files, sandpaper, super glue, thread locker, a cutting tool, a soldering iron, and a light plastic-safe lubricant or grease for the cam lobes. Clean away supports, strings, and rough edges from every printed part. Ream or drill only the holes identified in the guide, and test fit moving parts before using glue. Piston bores, bearing journals, lifter bores, and rocker arm pivots must move smoothly. When cutting or drilling, wear eye protection. Keep the power supply disconnected while soldering. We will begin with the engine block. Install the 36 disc magnets and the 2 threaded inserts in the marked locations shown in the PDF guide. Use an M3 screw as a handle when positioning each insert, and keep glue away from the internal threads. Check every magnet against a reference magnet before gluing it. Correct polarity is important because the timing cover, valley plate, oil pan, cylinder heads, and other removable parts must attach securely later. Ream the cam journal until a 6702ZZ bearing slides in with a snug fit. Then install the 10M 3x3mm screws in the marked locations. Smooth the cylinder walls and ream all 16 lifter bores. Each lifter should slide freely without excessive play. Next, prepare one cylinder head at a time. Each head uses 21 magnets, 8 threaded inserts, and 15M 3x6mm hex screws. Install the magnets and inserts only in the marked locations. Check magnet polarity against the matching surfaces before adding glue. Install the 15 hex screws. Then ream the valve stem holes slightly larger than 3mm so each valve can move smoothly. Repeat the same process for the second cylinder head. We can now prepare the removable exterior parts. Install 4 magnets in the timing cover, 4 in the valley plate, four in each exhaust header, four in the oil pan, and 4 in the intake manifold. Use the marked locations in the guide, and check every magnet against its mating surface before gluing. Finish the intake manifold by installing the 10M 3x6mm hex screws across the top. Now for one of the most important stages, the crankshaft. Lay out crankshaft segments 1 through 8, the crank gear, output flange, spacers, 13 bearings, screws, and nuts in assembly order. Build the crankshaft one section at a time, following the guide's numbered sequence. At every stage, align the grooves before tightening and check the measurements shown in the PDF. A small error at the beginning becomes a large alignment problem at the opposite end. Keep glue away from all bearings. After completing the dry assembly, place the crankshaft into the block and fully tighten the 5 main bearing caps. Rotate the crankshaft by hand. If it binds, check the connecting rod journals, bearing alignment, and segment orientation before continuing. Once the crankshaft turns smoothly, apply thin super glue only through the designated holes and between the printed mating surfaces. Let it cure completely. Test it in the block again, and confirm the crank gear sits about 8.5mm from the block or bearing cap surface. Next is the camshaft. Organize all 16 numbered lobes, the 3 types of cam bearing surfaces, 56702ZZ bearings, the threaded rod, nuts, cam gear, and set screw. Assemble the components in the exact order shown in the guide. Align every groove and check the dimension after each group is added. Use a small amount of thin super glue only between the printed mating surfaces. Do not glue the nuts, bearings, or cam gear. The cam gear must remain adjustable until its timing mark is aligned with the crank gear. Lock it later using the M3 set screw. The completed camshaft should measure approximately 175.5 millimeters. Add a light amount of lubricant to the cam lobes and bearing surfaces, then slide the assembly into the engine block. Each piston assembly uses one piston, one connecting rod, one bearing cap, one M3 by 25 millimeter screw, one nut, and two M3 by 16 millimeter bearing cap screws. Place the connecting rod inside the piston. Insert the nut into one side of the piston, then pass the 25 millimeter screw through the piston and connecting rod and tighten it into the nut. Center the connecting rod and make sure it pivots freely. Ream the connecting rod bearing surface so a 6701ZZ bearing fits snugly. Repeat the process until you have 8 complete piston assemblies. Install the pistons through the cylinder bores and connect each rod to its crankshaft journal. Secure every bearing cap with two 16 millimeter screws. Rotate the crankshaft after installing each pair. This makes it easier to find interference before all 8 pistons are in place. Install the rear main cover using 12 M3 by 8 millimeter screws. Next, mount the flywheel to the crankshaft output flange using 6 more 8 millimeter screws. Install the timing tensioner with 2 M3 by 8 millimeter screws. Align the timing marks on the cam and crank gears. Fit the GT2 100 tooth belt, then adjust the tensioner until the belt is secure without being excessively tight. Rotate the crankshaft slowly through several complete turns. The camshaft should remain timed and the assembly should move without binding. Makers, if this guide is helping you, take a second to like the video and subscribe. Almost 99% of our recent watch time came from viewers who were not subscribed. Your support helps us keep building and documenting more 3D printed engines. Now we can build the valve lifter assemblies. Glue 1/4 inch steel ball to the end of each lifter, then insert the pushrod. Adjust the complete lifter and pushrod length to 86.8 millimeters. Repeat until you have 16 identical assemblies. Install all 16 lifters into the prepared bores, then secure the 4 lifter guides using 4 M3 by 8 millimeter screws. Check that every lifter and pushrod moves freely. Each valve uses one M3 nut, one M3 screw cut to 42 millimeters, one spring retainer, and one printed intake or exhaust valve. Grind the threaded end of the screw into a smooth dome, then glue the screw head into the printed valve. Slide on the spring and spring retainer, and secure the assembly with the nut. Build 8 intake valves and 8 exhaust valves. Install 4 intake and 4 exhaust valves into each cylinder head, following the orientation in the guide. From the bottom of the cylinder head to the top of the valve stem, the height should be approximately 46.6 millimeters. Check that each valve closes fully and moves smoothly. Align the rocker rail on the cylinder head. Install 8 rocker arms and pins using 8 M3 by 12 millimeter screws. Each pin must slide smoothly through its rocker arm. Rotate and press each rocker by hand to confirm that it opens the valve and returns freely. For each valve cover, install 4 M3 by 6 millimeter hex screws and 4 M3 by 5 millimeter socket head screws. Repeat the rocker arm and valve cover assembly on the second cylinder head. Attach the completed driver's side and passenger side cylinder heads to the engine block, making sure the intake and exhaust sides face the correct direction. Slowly rotate the crankshaft through several full revolutions. Watch the pistons, push rods, rocker arms, and valves, and stop immediately if you see interference or a valve that does not close completely. To assemble the starter, insert the M3 nut into the starter drive gear and start the M3 by 4 millimeter set screw. Place the 500 revolutions per minute geared motor into the starter mount. Slide the drive gear onto the motor shaft and tighten the set screw. Secure the motor to the mount with 2 M3 by 8 millimeter screws. Install the completed starter on the engine block using 2 M3 by 40 millimeter screws. Before powering it, check that the starter gear meshes with the flywheel without binding. For the electronics, prepare Prepare the 2 DC female power jacks, the DC dongle, motor speed controller, and 12-volt 1-amp power supply. With the power supply disconnected, solder the motor leads to the motor side connector and solder the power jack wires. Connect them to the speed controller using the board's motor and power labels, and carefully check polarity and insulation before applying power. Plug in the power supply and begin with the speed control at its lowest setting. Install the valley plate, timing cover, oil pan, intake manifold, valve covers, and both exhaust headers. The magnets should pull each removable part into place. Before the first full speed test, turn the engine slowly and listen for rubbing, clicking, or binding. If everything moves freely, increase the speed gradually, and there it is, a fully working 3D printed Chevy LS3 V8 engine model. Ready to build your own? Get the complete LS3 hardware kit at makerrx.com and skip the search for dozens of tiny bearings, magnets, screws, and electronic parts. If this video helped you, like, subscribe, and tell us in the comments which engine should Maker RX build next. Thanks for watching, makers. Now go make something awesome.